In this video, we're going to be talking about concentrations. It's going to be a very brief video, just going over what our different concentration units are. In a further video, I'll do some examples on using these concentrations. By concentrations, we consider it to be an amount of solute in a given amount of solution, usually. There is one unit we'll look at where it will not be given amount of solution, it will actually be the given amount of solvent. So we're going to look at today molarity, molality, mole fraction, mass percent, volume percent, and parts per. Okay, so molarity, hopefully this is a review for you, but molarity is a very important unit that is used by chemists all the time. So we're going to use it in chemistry class. It is used for stoichiometric coefficients, which include solutions. You guys should have at this point have already used molarity in stoichiometry. So review that if need be. But molarity is given by an uppercase M as its prefix, or not prefix, as its abbreviation, and is equal to the moles of solute divided by the liters of solution. Okay, so again, this one should be a review. This next one, however, molality, is probably new to you guys. Molality is going to be lowercase m as its abbreviation. I guess I should do big M here. So lowercase m. So molality itself is a unit that's used because in colligative properties. So used in colligative properties, which we'll be talking about in a further video. And the nice thing about it is that it does not change value when temperature changes, which is why it's used for colligative property calculations. Okay, so the reason is because of the way that molality is set up. We actually are using solvent mass. So changes in temperature are going to change the volume, but not the mass, so we don't get a change in our molality value. So with our molarity, we generally don't look at different temperatures with that. So our molality, little m, is equal to moles of solute over kilograms of solvent. And again, this is solvent, not solution. So this is one of the ones that are weird, or the only one that's really weird. On the bottom, generally you're talking about the total solution. solute plus solvent, but here we're just talking about kilograms of solvent on the bottom. And again, because we are in mass, it does not change with different temperatures. So it's good for colligative properties. Our next one is mole fraction. It's given by chi, this x, kind of little fancy thing at the beginning. And mole fraction is used with when we want to see how amounts of moles of things are going to change things. We're generally talking about things in the vapor phase. So we're talking about when we're looking at vapor pressure and partial pressure. So using Raoult's law or Dalton's law. So used in Dalton's law. So our partial pressures. And it's used in Raoult's law. Which we will talk about in a further video. But Raoult's law, that's when we're trying to calculate vapor pressure. Of a solution. Okay? So, with mole fraction, you're just talking about the mole fraction of any substance. So it could be solute or solvent. So you have mole fraction of substance A is equal to moles of A divided by the total number of moles. Okay, and A can be solute or solvent. Doesn't matter. Okay, doesn't matter what part of the mixture it is. It's A. Okay. Next is mass percent. And this is a percentage, so it's a unitless quantity. It's used a lot in biological sciences and medicinal sciences. Okay. And it is specifically just a percentage. So you have a mass of solute over mass of solution times by 100. Only note here is that your masses have to be the same because they're going to cancel out. Okay. Volume percent is very similar to this. So it's used for the same. So it's used just like mass percent. And it again is a percentage. Actually, I guess I should do mass percent is in percent. And it'll be volume percent is equal to volume of your solute divided by volume of solution and times by 100. Again, volumes are in the same unit. Because they must cancel out. Okay. The last one is parts per. And we're going to look at, and it's parts per mass. So in terms of mass. This is used in medicinal purposes along with environmental sciences. Okay, so here we're going to look at both parts per million and parts per billion. But you could do parts per anything. You do parts per 100, parts per 1,000, parts per trillion, whatever you want to do. But we're going to specifically look at parts per million, which is abbreviated as ppm, where ppm is equal to mass of solute divided by mass of solution times by a million. So mass percent is the same as parts per 100, as a note. And your unit will just be ppm at the end of this. Then parts per billion, ppb, is going to be mass of solute, mass of solution, times by a billion. Okay, just a note, as long as your masses are the same unit, you can use any mass unit. You can also use this with volume, again, as long as they're in the same unit. And you just use ppm as your unit if it's parts per million, ppb if it's parts per billion. That's everything. Thanks for watching. See you guys later.